T. Some basic concepts of chemistry. Chemistry deals with the composition, structure, and properties of matter. These aspects can be best described and understood in terms of basic constituents of matter, atoms, and molecules. That is why chemistry is called the science of atoms and molecules. Importance of chemistry. The importance of chemistry is that it is the study of you and the world around you. Chemistry has a reputation for being a complicated and boring science, but for the most part, that reputation is undeserved. Fireworks and explosions are based on chemistry, so it's definitely not a boring science. If you take classes in chemistry, you'll apply math and logic, which can make studying chemistry a challenge. However, anyone can understand the basics of how things work. And that's the study of chemistry. In a nutshell, the importance of chemistry is that it explains the world around you. Chemistry explains. Cooking. Chemistry explains how food changes as you cook it, how it rots, how to preserve food, how your body uses the food you eat, how ingredients interact to make food. Cleaning. Part of the importance of chemistry is it explains how cleaning works. Use chemistry to help decide what cleaner is best for dishes, laundry, yourself, and your home. Use chemistry when you use bleaches and disinfectants and even ordinary soap and water. How do they work? That's chemistry. Medicine. You need to understand basic chemistry so you can understand how vitamins, supplements, and drugs can help or harm you. Part of the importance of chemistry lies in developing and testing new medical treatments and medicines. Nature of matter. Anything which has mass and occupies space is called matter. Everything around us, for example, book, pen, pencil, water, air, all living beings, etc., are composed of matter. You know that they have mass and they occupy space. Matter can exist in three physical states, that is, solid, liquid, and gas. The constituent principle of matter are present in these three states. In solids, these particles are held very close to each other in an orderly fashion, and there is not much freedom of movement. In liquids, the particles are close to each other, but they can move around. However, in gases, the particles are far apart as compared to those present in solid or liquid states, and their movement is easy and fast. Different states of matter exhibit the following characteristics. 1. Solids have definite volume and definite shape. 2. Liquids have definite volume but not the definite shape. They take the shape of the container in which they are placed. 3. Gases have neither definite volume nor definite shape. They completely occupy the container in which they are placed. Classification of matter. At the macroscopic, a bulk level, the matter can be classified as mixture of pure substances. Many of the substances present around you are mixtures. For example, sugar solution in water, air, tea, etc. are all mixtures. These can be further subdivided. A mixture contains two or more substances present in it, which are called its components. A mixture may be homogeneous or heterogeneous. In a homogeneous mixture, the components completely mix with each other and its composition is uniform throughout. For example, water and sugar. In heterogeneous mixtures, the composition is not uniform and sometimes throughout the different components can be observed. For example, the mixtures of sand and water. Pure substances have characteristics different from the mixtures. They have fixed composition, whereas mixtures may contain the components in any ratio and their composition is variable. Copper, silver, gold, water, glucose are some examples of pure substances. Pure substances can be further classified into elements and compounds. An element consists of only one type of particles. These particles may be atoms or molecules. Two or more atoms combine to give molecules of the element. Thus, hydrogen, nitrogen, and oxygen gases consist of molecules in which two atoms combine to give their respective molecules. When two or more atoms of different elements combine, the molecule of a compound is obtained. The examples of some compounds are water, ammonia, carbon. Properties of matter and their measurement. Every substance has unique characteristics. Based on characteristics, properties can be classified into two categories: physical properties and chemical properties. Physical properties are those properties which can be measured or observed without changing the identity or the composition of the substance. Some examples of physical properties are color, odor, melting point, boiling point, density, etc. Chemical properties are those properties which require a chemical change to occur. The examples of chemical properties are characteristic reactions of different substances. These include acidity or basicity, combustibility, etc. Many properties of matter, such as length, area, volume, etc., are quantitative in nature. Any quantitative observation or measurement is represented by a number followed by units in which it is measured. For example, length of a room can be presented as 6 meters. Two different systems of measurement, that is, the English system and the metric system, were being used in different parts of the world. The metric system, which originated in France in the late 18th century, was more convenient as it was based on the decimal system. The need of a common standard system was being felt by the scientific community. The International Systems of Unit, SI. These units pertain to the 7 fundamental scientific quantities. The other physical quantities such as speed, volume, density, etc. can be derived from these quantities. Mass and weight. Mass of a substance is the amount of matter present in it, while weight is the force exerted by gravity on an object. The mass of a substance is constant, whereas its weight may vary from one place to another due to changes in gravity. You should be careful in using these terms. However, its fraction, gram, 1 kg is equivalent to 1000 gram, is used in laboratories due to the smaller amounts of chemicals used in chemical reactions. Volume. Volume has the units of length cube. So, in a SI system, volume has units of meter cube. But again, in chemistry laboratories, smaller volumes are used. Hence, volume is often denoted in centimeter cube. Density. Density of a substance is its amount of mass per unit volume. So, SI units of density can be obtained as follows. SI unit of density equivalent to SI unit of mass by SI unit of volume. SI unit of density is grams per centimeter cube.